Hello folks, this is the new electro-hydraulic actuator from Rotex. This electro-hydraulic actuator is self-contained, explosion-proof, certified system. It has different components. This is the control unit with the display and the keyboard. Here is the terminal block where you can provide customer supply and remote input outputs. Here is the control unit is attached to the oil tank. This is a 90-liter oil tank with oil gauges provided showing the minimum oil level required and the maximum oil level required. The oil tank is provided with a breather. Then we have the motor and the accumulator to control the pressure between certain level of pressure. We have the manual selector knob and the manual hand pump to manually open and close the valve when power is not available. This is the cylinder of the actuator, and the position of the valve is transmitted to the control unit via position transmitter. Then we have here we have two PRVs with a filter to maintain the pressure level, and if the pressure level goes high, it will be the pressure is relieved here. Now we have to configure the system for different accumulator pressure levels and other settings. For that you will have to go into the menu using this knobs and display for navigation. To go inside the menu, you can press the knob this way and press the red knob 4 times this way. You will see the main menu. The main menu has the basic setup, the calibration menu, the advanced setup, and the diagnostics. So we can go inside the basic setup this way by pressing red knob, and then you can see the accumulator settings. Here you can set the accumulator max setting and the accumulator min setting, between which the motor will maintain the pressure for the cylinder operations. Then we have a low pressure setting, below which low pressure fault is detected, and for after a certain period, if the motor is on and the pressure is not increasing above the low pressure, it will detect hydraulic fail. Then we have tight shut-off setting. So this tight shut-off setting, if set as yes for open or close, it means that the valve will be fully open or closed until the mechanical end limits are reached. So if you press it, you can change it to no, and then it will open only up to the electrical limit. And if you press it as yes, it will be until the mechanical end limit. So you can change it as per your requirement. And there is this LED close configuration, which is used for setting the dome as red indication for close, green indication for open. So the dome is provided at the top. So if you set it as green for close, it will show as green in the close condition and red as open condition. Now we will go into the calibration, which is the first procedure to be carried out after the valve is attached and the mechanical end limits are set. Here you can set the open limit. Now select set limit and then press the blue knob upwards. The position will change and it will try to reach up till the open mechanical limit. If the position is not changing, release the blue knob and press the red knob downwards. The new value will be set, which will be the open end limit for the calibration. Similarly, you can set it for the close limit. Again, you select the set limit menu parameter and press the blue knob upwards. The valve, you can see the position of the valve is decreasing and moving to the close condition. Once it reaches the close condition, the position will stop changing, which means the mechanical end limit has reached for close. The valve is continuously closing, and during that period you have to press this blue knob upwards continuously. If you release the knob, it can stop, but again you can press it upwards. The valve will continue closing, and now it has reached the mechanical end limit for close. Press the red knob downwards. The new value is set, and in this way the open close limit calibration is done. You can also do PST calibration by pressing the red knob downwards for setup start. Now the valve is moving from close to open and then close condition this way. During this process, it will monitor the position and pressure for PST calibration. As you can see, now the valve is moving in the open direction, and during that time the dome is blinking green. Now the valve is closing. This is the last part of the PST calibration. During this process, the dome is blinking red. Here in the display you can see different solenoid valves are indicating that the close is going on. Different solenoids will be turned on while opening. Now PST OK is displayed. indicating that PST calibration is done. Now we'll go to other settings. In the advanced setup, we have provided a setting for relay contacts. There are such 8 relay contacts. You can set it for different events and faults this way. Such 8 relays are provided. We have now in the advanced setup partial stroke test, which you can carry out in open condition by just pressing this red knob. Presently it is closed, so we will have to open it to carry out this partial stroke test. Similarly, for full stroke test, we have provided this local menu. We'll now see some open and close operations and PST operation. Presently it is in the local mode. Now when the red knob is downwards, here it is in the local mode. You can operate this valve by the blue knob. If the blue knob is pressed downwards, you can open the valve. The valve is now opening and position is changing accordingly. Whenever the pressure goes below a certain level, automatically the motor will turn on. Valve, here the cylinder is moving, as you can see, for opening the valve. Now we'll close the valve by pressing this blue knob upwards this way. Now the valve is closing. Here we have seen locally open and close of the valve. Now we will see in the remote mode opening and closing of the valve. We have here provided some open and close remote inputs. So to open the valve, you will press this push button and you can see the valve is opening. You can stop this valve in between by pressing the stop button. You can see the position has stopped changing. Now we'll close. The valve is now closing. Now we will see the EHD feature of this actuator after this. For that we will first open the valve. To carry out EHD, we will have to first remove the 24 volt DC provided in the actuator for EHD input. After the actuator has opened this valve, we will then carry out EHD. Here we have given a 24 volt supply for the EHD signal. Now we will remove the EHD signal. As soon as EHD signal is removed, the EHD signal, after it is removed, it remains in the open condition, which means this is a fail-safe open valve. Now, in this condition, you cannot carry out any manual open and close, because in the EHD condition we cannot allow manually open and close the valve. Also, we cannot carry out any close operation from here. Similarly, you cannot do any open and close operation from the remote input. In off mode, we have provided a system by which EHD signal, even though not available externally, the EHD coil is energized so that you can manually open and close the valve in EHD condition. In the off mode, you cannot carry out any open close condition by the blue knob, but if you want, you can go to the manual mode, and now you can see, even if EHD is not there externally, the valve is closed. So this is the new feature in this EHF, electrohydraulic actuator. Now we'll even open the valve. Now we'll do one thing, we'll again give back the EHD signal. As soon as you give back the EHD signal, you will get a message, reset local EHD, which means the valve will not be activated unless you give the you reset the EHD signal. To carry out reset of the EHD signal, there is a procedure. You have to keep this in remote mode and then press the blue knob upwards and then downwards. Now the reset, due to which the EHD is now acknowledged, and then you can carry out close and opening of the valve. So in this way the EHD operation is carried out in this actuator, and when EHD is not there, you can also do it manually when you keep in the off mode. So you can see now we are opening and closing the valve as EHD signal is available. Now we will again carry out EHD in closed condition. Now the supply is available. I will remove the supply again for EHD. You can see from closed condition it is moving into the open condition because EHD signal is not available and is in EHD condition. So in this way the EHD operations is carried